Good afternoon, everyone. It's me, Craig, again, and thank you very much for attending our webinar on the second day. So today we will have four topics. One will be given by our Indian service manager, Shad, and the second one I will be the speech giver to give you an introduction about the residential solution. And third one, our system application manager, Lucas, will give us an introduction about export power limit solution. And the last one will be our engineer, Jack, to give you an introduction about our energy storage solution. And okay, so let's begin today's webinar. Okay, so first, James will give us an introduction about GoodWe cooperation introduction.
Hello everyone, good afternoon. This is James from GoodWe. I'm heading the business for GoodWe India. First, I would like to give my warm greetings to all the friends there in India. Definitely it's been a difficult time for all of us. Here in China, we would say, judging from the current situation, we have pretty much overcome the coronavirus. So we do hope that India would get over it very soon. By that time, I will be able to visit you again, which I'm very much looking forward to. And so back to the business side, I would take this opportunity to thank all my customers for your continued support. Without your support, we couldn't have made GoodWe such a successful brand in India, especially in the commercial and industrial projects. And special thanks goes to Tata Power, Sterling Wilson, Adani, and also Renew Power. So definitely we will be improving our service and products to make you even more satisfied with GoodWe. Okay, so here today I'm standing at GoodWe Exhibition Hall. So with all our culture, network, service network, product portfolio, and energy management solutions displayed here. Okay, so let's go take a look. Here is the first part where we will get started. This is the GoodWe family. So GoodWe see a lot of importance for these talents, which we would consider as the most precious asset for the company. So every year we organize different activities to bring together different teams to create close connection between them, and so that will help improve the daily work communication to make it more efficient and effective. Here we will see the spring and autumn outdoor tours, the sports matches, and this one I want to mention especially that our company has won the Best Employee Award in the city for 3 years in a row. So that pretty much explains how we make our employees love the company. And here we will be seeing the GoodWe global team. So for now we have around 60 overseas employees working from different countries. And so every year we invite them back to the headquarters for 2 weeks. And during that time, we'll help them to get better understanding of the company culture and strategy. And also we'll be given a lot of trainings on the product. So after that, we will issue the qualification certificate for them. With that, they will be able to give the trainings in their own countries. And here is the football match played between GoodWe China taking on the GoodWe International. It's quite fair game, I would say, and no doubt GoodWe China won. Okay, here is the next part, the GoodWe presence in the global market. So for now, we have 14 offices spread across the globe. The Germany office as the headquarters for Europe, and India, that's in Vashi, Mumbai, you would have known that, and all the other offices. So we have the sales team set up there, combined with the service team, and also the components kept there, spares also, and repair center maybe in some countries also. So just to ensure the highest level of satisfaction will be delivered to our customers. And here we come to the product sector. So as a salesperson, I would say thanks to the brilliant design of the product, so that has literally reduced the difficulty to convince customer when we're doing the sales pitch in front of customers. The unibody cabinet design just to ensure the highest level of IP65 protection, and the aluminum die cast upper cover will give you the best impression on the product, the very fantastic look. So in GoodWe, we can generally we can split the product into two categories: the on-grid inverters and the hybrid inverters. So for the on-grid inverters here, up till now, here we have the single-phase on-grid inverters. So from a 700 kilowatt to 3 kilowatt here, this one, you will see the very compact design, just the size of a A4 paper. And this, I will mention that that's a very unique design for the high-end customers. So with all the fancy features integrated, and even the display, that's the colorful display. This again for the general market, 3 kilowatt up to 6, single phase, 2 MPPT. This is the single phase, 5 kilowatt up to 10. And 3 phase started from here, 4 kilowatt up to 20 of this size, 25 to 36 kilowatt. And this one, the super model, I would say, for Indian market. So thanks to this product, so that's how we can make GoodWe the most popular brand in India CNI sector, the 50 kilowatt, 60 kilowatt, and 100 kilowatt. And okay, so now it comes to the storage sector. So for storage, we have the typical bi-directional hybrid inverter as well as the retrofit device. So the hybrid inverter, we have 3 kilowatt up to 10 kilowatt, and the retrofit, so we have that for the AC retrofit, and this one that's the for US market, the hybrid inverter for US market. Okay, so now we come to the super model again. So this is the HT series, 100 kilowatt, 120 for the rooftop, and 250 with 1500 voltage DC. So that's for utility scale projects. Here we have the 12 MPPT with 24 inputs. So that's gonna be a super model again in the market. So that will be available in around 2 months' time. So we all will be waiting for that. So let's get to the next part for the energy management system. Okay, this is our energy management system for industry. So let's say 8 a.m. in the morning, so that's beginning of the day, the energy consumption is not that much, so everything can be supplied from the storage systems actually. So now it comes to 11 a.m., so the power consumption is really big. Then, so the storage system will continue to supply, as well as the PV system will be 100% supplied to all the loads. And even you may, because the consumption is big, maybe you need to take some power from the grid. So all the load consumption will be displayed here. So maybe you can choose to shut down some unnecessary loads just to save the electricity bill maybe. Okay, now it comes to 5 p.m. So the PV generation is less, and also the power load consumption is less. So yeah, you would stop buying the electricity from the grid, and so all the load consumption can be supplied by the storage system. So it's 12 a.m. in the night. You can charge the energy storage system from the grid because it's off-peak hours, right? So the electricity price will not be that much. So in that way, you can save your cost as well. Now 3 a.m. in the morning, you can allocate your power to supply other factories and some families as well. So that's we call the allocation of the smart allocation of the power. So that's the concept about our industry energy management system. Okay, let's get to the residential part. Okay, for residential energy management system, we have four modes actually. We have the working daytime mode, we have the nighttime mode, weekend mode, and we have off-peak mode. In the working daytime mode means we're out for work, right? I mean, there will not be much energy consumption at home. So then your PV is giving generation. So then through the hybrid inverter, it will feed the power into the grid. So now it's the evening time, we've come back home from work. So then because there was no PV generation by now, then the battery system will discharge to power the household loads. And even during this time, you can choose to charge the battery through the grid, I mean during off-peak hours. Now we come to the weekend. So during the weekend, people are home, right? So the energy consumption in house will be big. So then the PV power will directly power the household loads then through the inverters. Okay, so now the grid is off. How the PV system can help you. So during daytime, the PV system will go through the hybrid inverter to power your loads, even without any grid connection. So for the night, without grid connection, then the battery will just discharge the power to power your household loads. So that's pretty much about the residential energy management system. And so I want to bring your attention to this unit also. So this one is the all-in-one product we're doing. So that just gives you the ready option for energy storage system. With this single unit, you're pretty much ready with the very advanced concept of doing the energy management in your house. Because back there, all the household loads, I mean, you can choose to use our smart plug. So by using the smart plug, you can control the switch on and switch off of different loads. I mean, at different times, because the major purpose is to save your electricity bill. So for some loads, you can choose to to switch on later in the afternoon, maybe instead of 11 a.m. when the consumption is at its peak time. So this kind of a smart control of the loads will help you to save your electricity bill. And this product, we have the hybrid inverter on the top, then the switch box in the middle, then down there at the bottom we have the battery box. So yeah, thank you everyone. That's pretty much about the GoodWe exhibition hall, and I'm going to just want to present to you all. Thank you very much for your time.
Thank you very much for James sharing. And I think you've already learned about something about our products and also the GoodWe culture. So next, we will invite our Indian service manager, Mr. Chad, to give you an introduction about our Indian's business and some project references. Okay. Hello, Chad. Hello, Chad. Can you hear me?
I'm audible. Hello.
Okay. So let's welcome Chad to give us the introduction about our Indian references.
Yeah. Hi. Good afternoon, everyone. Myself Chandrakant, taking care of service in India for GoodWe. So I have joined GoodWe project references. We will explain about GoodWe team in India. Coming now. Internet data. So I will switch off my camera. So that's why. So this is the first big project which we have done in India. So that's Cochin Airport, 10 megawatt. Which is hello. We will see some project reference which we have done in India. That first one is Cochin Airport, which we have done in February 2019. So EPC is Sterling Wilson. Here they have used our 60 kilowatt inverters. That is 141 numbers. Here it is a mixture of parking area as well as the ground mounted. So here if you have Cochin Airport, then you can see red color inverters. So that's belong to our GoodWe. The next project reference is we have 6 megawatt which we have done with Mangalore refinery. It is in Mangalore. So EPC done by Tata Power Solar. So this is commissioned in May. So this project is first megawatt scale project commissioned by GoodWe in India. So next month we are completing 2 years for this project. So here we have inverters mix of 50 and 60 kilowatt, which are 95 numbers. Then next one is we have from Bosch. So this is a Bosch factory near Bangalore, where they have used our 60 kilowatt inverters, 54 numbers. EPC is done by Bosch. So you can see how they have utilized the space by installing use of space available there. Power in Bangalore, it is 1.3 megawatt recently done in February month. Here they have used 60 kilowatt inverters, 13 numbers. Then we have another project that is in ITC Kapurthala, that Punjab 1 megawatt. commissioned in April 2019. EPC done by Tata Power Solar. And inverters used here is 13 numbers. Then we have another inverter called so this is another project which we have in Gujarat, that is a Coca-Cola factory in Sanand. That is a 897 megawatt. In 2019, we have done. So inverters are next project we have is Nerolac Paints, which is in Bharuch. That is 1 megawatt, which is commissioned in November 2018. And EPC is done by Tata Power. Inverters are 60 kilowatt, 12 numbers, and 25 kilowatt, 2 numbers. Then another project which we have is in GE, that is near Pune. So 1 megawatt. This is also commissioned in November 2018. EPC is done by Tata. Inverters are 60 kilowatt, 16 numbers. Here we have used. Then another project reference which we have is from Pune itself. That is a Flash Electronics. It is in Maharashtra, 1 megawatt. It is commissioned in February 2019. EPC is done by Sterling and Wilson. Here they have used inverters 60 kilowatt 10 numbers and 50 kilowatt 6 numbers. This is a complete industrial rooftop projects. Then we have prestigious project in Tata Consultancy Services in Mumbai. So this EPC is done by Tata. Here they have used 50 kilowatt 1 number inverters and then 60 kilowatt 2 numbers, 20 kilowatt 2 numbers. Another projects we have in Nagpur, that is Ramdev Baba College. This is a college rooftop they have used for generating solar power. It is commissioned in March 2019. EPC is done by Tata Power Solar. So inverters they have used is a 6 and 1 number 25 kilowatt. Another projects we have is Siemens. It is in Aurangabad. So here EPC is Tata Power Solar. They have used 50 kilowatt 14 number inverters and 25 kilowatt 1 number inverters. This is 1 megawatt plant commissioned in October 2018. Then we have one plant which is under commission, that is from Microtech, that 13 megawatt with our 80 kilowatt inverters, 166 numbers with PLC communication. So this is the site where in India we are going to do first time. So PLC is available with our MT series inverter, that is 50, 60 and 80 kilowatt. Now we will see some details about our team in India. So this is our global presence. So like we have subsidiaries in 14 countries and service offices like Germany, Italy, Turkey, India, then China, Holland, UK, Mexico. This is our India office. We have our head office in Mumbai, which is located in Vashi, in Navi Mumbai. So this is our service team members. So this is our service team network. So still existing, we have 15 numbers of service engineers all over India. So we have all major cities like Delhi, Mumbai, Ahmedabad, Bangalore, Chennai. Then we have one central engineer in Durg. And in future, we have plan of 20 service engineers. After that, we are also adding some service partners, which will be take care of Pan India. So this is from GoodWe service. So whatever be you have any problems, you can get our contact details from our sales managers or from our website, or you can contact us directly from this landline number. we, right now we have this service engineers which is directly contacting the customers to give support if they have any problems in service and any problems in inverters. So we are very happy to serve. So as we know, service is very important part whenever any company comes. So we are almost now 3 years old, and lot of customers already knows our details. So and we have one ticket system on our website also. So that is already working for China. Then in next month we are planning to take a service call from that website, which is available on our GoodWe official website. There you can register your complaint, and we will reach out to you for resolving your complaints. So thank you very much. If you have any queries or any questions, please kindly reach me out at my email ID chandrakant.sonawani@goodwe.com. So we are very happy to serve you and help you to service our inverters and do the installation, commissioning, everything. So it is over to Craig now.
Okay, Chan, thank you very much for your sharing. Okay, thank you. Okay, so next, it's me right now, and Craig. I will be the one to give you the introduction about our residential solution. Okay, so let's begin. So for GoodWe's residential solution, so basically it is consisted of four major parts. So first one, sorry. Okay, so first one is the inverter. Okay, second one is the optimizer. Okay, third one, the residential energy storage system. And the last one is our SAMS portal monitoring solution. So for the first one, inverters. So right now, you've already familiar with that. We have the inverters with the capacity range from 700 kilowatt up to right now should be 10 kilowatt for single phase series. So as you can see, we've been awarded this award, the EU PD research in the category of top PV, top brand PV for almost right now should be 4 years. So in the this awards are actually awarded by those main markets like some mainstream markets like Australia and the Netherlands. So it can be treated as an approval of our residential solutions advantage or quality in the market. So the second one is the optimizer. So right now, as you can see, we have established a deep cooperation with the Tigo optimizer company. So their main markets right now on the market are their different kinds of optimizers with different functions. So later for this part, I will introduce in the next few slides. So right now, we've already integrated the Tigo's the data logger called CCA into our DNS and also SDT. One is a single phase, another is three phase Ungri system, Ungri inverter. And also from the software, we can also get the data. We have a deep integration with the data part as well, because the clients can see module level data on our SAMS portal. So from both hardware and software, we have a very deep integration with Tigo solution. So the third one is our energy storage solution. So right now we have the single phase and three phase hybrid inverters, and they are compatible. We have both hybrid solutions and also AC retrofit, AC couple solutions. So basically, almost all the clients can choose the most appropriate energy storage system or solution based on their current system. Like if you don't have a energy storage one, you can choose to use our hybrid inverter like ES or EH or the ET from the 3-phase to build up an energy storage system. And also different models can compatible with different kinds of batteries like low voltage batteries, high voltage batteries on the markets. And also if you already have a existing on-grid system, like if you install like a 3 kilowatt on-grid inverter, you can choose to add a AC couple unit called like SPP, and that will make your system into a hybrid one. Okay, so that's basically the energy storage system. So the fourth one is our SAMS portal. So we have our own team to develop the platform, the monitoring platform, and also do the maintenance of these platforms and apps. So basically, we have our own team to do the whole job, not like some other brands or competitors. Some of them they don't have their own app or monitoring platform. They just outsource to some third-party company to do the job. So basically, if you have, for example, the most advantage of our SAMs is that if you have any requirement or demand on the monitoring part, you can just simply turn to us and let us know your specific demand. That means we can respond quickly, we can add this function quickly, and to allow you to use it as soon as possible. So that's basically about the SAMs. So also I think Simon already have introduced the detailed parts about the SAMs yesterday. Okay, so that's basically the 4 major parts of GoodWe residential solution. Okay, so next this slide will be used to introduce several different parts about our inverters and the solutions. So first one is the considerable features for residential applications. So you can see that the reason I put this feature first is that because it's a residential solution, the first point we want our customer to understand, to feel is that the inverter is actually it's very suitable for your house, right? Because you need to use it at your house. So that's why we put this one in the first page. So we have the white color, we have the die casting case, okay, and with the piano paint on it. It's actually like traditional residential appliance for your house. So and also I think based on this design, we've been awarded Red Dot Design Award for our DSS models. So I think also not now, maybe in the future, this point will still be our first selling point of our residential solutions. Next one is size or the dimensions. So extreme compact design. It means that our inverter has a very, very small size or dimension, even the weight. So like the XS is actually right now one of the smallest models on the market. The size of this cover here is about like similar like A4 paper. So you can imagine how small it is. And the whole capacity, the whole dimension or the volume is about nearly 30% smaller and lighter than the biggest residential models on the market. So based on this design, for the installer, it's very convenient for the installer to do the installation, to bring the inverters to the site or to your client's house. So it can save for some how to say, so you can actually save some cost, not only on the installation part, but also save down some transportation, or save down some labor's cost as well. So also for our distributors, so when you actually when you place order to us, you can, for example, you can put more residential inverters in one container, right? So you will actually somehow you will actually save the transportation cost as well. So that's basically another feature we promote here of our GoodWe residential solution. So on next page, I think the high quality screens are also very popular for the markets right now. As you can see, from the first generation of GoodWe's residential inverters, like the SS and DS, we've already implemented our screens, the screens on the residential ones. And right now, because we have the third generation, the XS, DNS, and also the flagship DSS, you can see all of them here, all of the series, all of the residential series have the screens. No matter how big, how small it is, we also provide the screens, okay? So you can see the screens is not just a screen. We also have the indicators, okay? So we have indicators for different series. You can see that we have the like a running indicator. It will indicate the status of inverter. We will also have some indicators like alarms, right? And based on the indicators and screens, we have the buttons. Okay, so the buttons are used for the clients or installers to do the configurations, to do the local monitorings, to check some monitoring specs or something like that. So basically, for example, for smaller inverters, we have a single line screen, and you need to use one button to scroll the screen to check different specs. But for a bigger one, like the SDT three-phase models, we can use a screen to not only just check the data, but also it is able to show the curves, okay? To show some blocks, curves, and also with some vivid information, okay? So that's basically what we have. And I think most of you will be familiar with some other brands, you know, that because compared with GoodWe's solution, most of their residential models they don't have the screens, okay? They don't offer screens for you. So basically, if you use their models, the first problem you will have will be it is very difficult for you to do the commission, right? You need to use a laptop with a USB cable. You need to use your smartphone. Maybe not everyone have that, or maybe eventually it's not the best solution that for a screen without for inverter without screen, right? So our principle here is that we are going to continuously offer the inverters with screens, because we know that it is necessary part or accessory on the inverters. Okay, next part. So right now, this is our new generation of the communication stick. Okay, so basically it has a function, which a similar function like our traditional communication stick module. We have Wi-Fi, we have LAN, and we're going to have a Wi-Fi plus LAN. Okay, so Wi-Fi plus LAN is not just something. It sounds old because it's just Wi-Fi and a LAN, but for our clients, or especially for installers, when you choose a stick with Wi-Fi plus LAN, you can have you can improve your installation experience. You don't need to think about whether your client's house have a Wi-Fi router close the inverter or not. So you can choose which one you want to use at a site with just one communication module. Okay, so that's Wi-Fi plus LAN module, and also we are going to have the 4G module. Okay, so before 4G we have the GPRS module, and this module is actually only available for the models, GoodWe models in India right now. And we are going to have our 4G module, okay? So 4G module, so you can easily understand that the speed of the 4G will be much, much faster than the 2G for sure, okay? And also the compatibility of the local communication carriers will be much better, and you can freely choose the SIM card or the service, data service you want to use in your local, among your local carriers. So that's 4G module. And also we are going to have our Bluetooth module. So Bluetooth module is basically used for the fast commissioning and the local monitoring. So fast commissioning. So right now we use Wi-Fi, and also for some special cases, clients will choose to use RS485. But basically, you will need to use Wi-Fi to do the commissioning job. But in the near future, we're going to publish our Bluetooth module. That means you will have a much static communication between your smartphone and the inverter, and it will make the commission more and more convenient, more and more fast, and more stable for the installers. So that's our communication sticks. So next part, so just now I've introduced a Bluetooth module, and we are going to have we already have this. This is called SolarGo app. So with this SolarGo app, plus the Bluetooth and the Wi-Fi module, you can do a very, very fast commissioning just with 3 steps, okay? So on this SolarGo app, first you need to choose the stick, the communication stick on your smartphone. Then go into the SolarGo app, choose the device you want to connect. Then third one, also the last step, is just set the times and the safety option of the inverters. So the safety option or the grid connection is basically the settings catering to your local grid or the Indian grid. So you need to choose India, the safety option, and choose the grid type you're currently use or currently connecting to make the inverter work immediately. Because there are only 3 steps for the installer to do the commissioning using SolarGo, and plus some communication modules. So the SolarGo cannot only for commissioning. It is also designed for local monitoring. Okay, so it can realize, or it can provide 4 major information for you. The first one will be the running date. Okay, so the running date means that once you do the commissioning and you connected your SolarGo app to the inverter, you can check the basic dating at DC side or AC side, and in the specific parameter page. And also you can check overview status, or you can check the overall status on the overview page. Okay, you can check the power generation today or total, and you can check whether the power flow between the panels and the grid are good or not. The second one would be the alarm. So if something happened, and so you can open your SolarGo connected to the inverter and go to the alarms page to check the fault or the failure happened. Basically, you can see on the screen, you can just click the fault and you'll jump to the detailed page, including the fault description, the fault code, and also some simple SIP for the installer to reset or to solve the problems. And also we will put some we'll have some instructions like to tell you if you cannot handle that, you need to, what kind of problem you need, for what kind of problem you need to turn to us for the detail of the service help or assistance. So that's alarm function. Another one is very significant function, I think, is called a firmware update. So I think for most of the installers here in the webinar, you will have an experience like no matter what kind of brands you are using right now. So when the manufacturer, the inverter manufacturer, asks you to update the firmware of the inverter, it's pretty difficult because you need to bring your laptop, you need to actually to receive the firmware from the manufacturer and copy into your into laptop, and you need to download certain flashing software to do the updating. So that's pretty difficult or inconvenient. So with our SolarGo, you can just use your smartphone with the firmware for the DSP or ARM downloaded in your smartphone, and just click upgrade to update the firmware of the inverter you connected. So that's pretty convenient for most of the installers in our webinars. So last part is the settings. So settings basically it's about the advanced functions we offer based on our inverters. So for example, we can there is a function like you can set the PF value. You can choose to let the inverter to output like certain reactive power or something based on your demand. Also, we have some other functions like if you use a third-party data logger, here you can set the RS4 file, the Modbus address here. So based on the requirement from those third-party data logger like SolarLog, like some other brands. Okay. So basically, it's a very convenient app, and if you are familiar with our SAMS portal, the one which is designed for the monitoring, so this one you should download it and try it because it's very convenient for our not for the existing users to do the settings, to do the local maintenance. So next one is about the optimizer part. So it's an introduction about the flexible optimizer solution. So here we have a house, and we have some we have the panels and the inverters from GoodWe, and right now we have some optimizers from Tigo installed on this house. So I will use this example to give you introduction to give you an idea about how they are working and how convenient you can choose. Okay. The first one, you can check the yellow part, or I will call them yellow covers, okay? So with the yellow covers, they are actually the Tigo optimizer products, okay? So their function is here. You can see that on this house, we have the shadows from the nearby tree on these panels. So that's why we install the yellow covers. So the yellow covers can work independently to reduce the influence of the shadows, which means they can reduce the influence on the of the shadows or some dirty stuff covering the panels, which caused the drop down of the DC voltage. So that's the main function of these yellow covers. Okay, so they are optimizers. So for the blue covers. So these blue covers are called monitoring, Tigo monitoring, okay? So these monitoring modules or optimizers, they are installed to perform module level monitoring functions, okay? So with the modules, with the optimizers of these blue covers installed on your rooftop, you can realize module level monitoring on our SAMS portal, okay? You can check each panels or each modules basic DC parameters are DC voltage, DC current, and the total output, something like that. So that's basically used for the clients who want to have module level monitoring. So here we have another two white covers. So these are diode junction box. So they don't have any monitoring or optimizer functions. But the reason that we put here is that if the clients if the clients want to upgrade their covers, to some high level covers like a yellow one or a blue one. So they can just simply replace the covers with these ones, okay, to realize a function. So that's pretty convenient. So, and the function, actually, so they are working just like a junction box, like the one at the back of the module. But the advantage of this white covers is that the design is pretty different, like compared with the traditional panels junction box, because the components on the diode box here, they are actually not simply closed to the panels or to the cells. Okay, so the heat dissipation function is much better, and also if something caused a fire at the back at the junction box, you can simply replace it. Not like the traditional one, you cannot replace the junction box of the PV panel, right? You cannot replace it. You can just you can only replace the whole PV panel. So that's the advantage of this diode junction box cover. So on the next page, I will give you some idea about the difference between ours. Ours means GoodWe plus Tiger's solution with others solutions. So the first one will be, I would like to introduce is, this is a solution from inverter company from Israel. And they are, their feature is that they require 100% deployment of the optimizers at the back of the PV panels. Okay, so for the clients, you don't have choices, right? If you want to make your whole system to work, you need to install all the all the optimizers. So so if you compare with this one, that means even if you don't have shadows on these panels, you still need to install optimizers, right? So that's pretty a lot of cost. So you don't have choices. If you want to make the inverter work, you need to install all the install the optimizers for all the panels. So that's their requirement. So compare with ours, you can see that just in the previous example, you can see that we don't require 100% deployment of all the optimizers at for all the modules. And also you can choose what kind of optimizer you want to use based on your real demand, right? So we offer you choices. We don't need to spend a lot of money on the optimizers. Okay, so that's the first comparison. The second one you can check here. So already, if you know about Tigo, or you've already have some knowledge about that, and if you heard about some inverter manufacturer promoted this similar solution, I will give you a brief idea about what they are doing right now. So for some companies who claim that they are also compatible with Tigo, their solution will be like this. So first, you need to install the optimizers for the at the back for sure, and for the data transmission line, the system here, the data of all the optimizers will be collected by this one called TAP, the Tigo Access Point. So this device will collect the data, then transmit to this one called this data logger called CCA. Okay, and with the CCA connected to the internet, all the data will be uploaded to Tigo's server, and you can use Tigo's app to check all the data of the optimizers here. Okay, and the inverters here, they will also have their own monitoring system, right? Just like a traditional one. Then on their monitoring system, you will check the power generation, some fault happened, some basic monitoring specs. Okay, so basically, you can find that these are two separate monitoring systems. Okay, so you need to use two apps to do the monitoring, and there are no data interaction between the optimizers and the inverters. So basically just buying two different systems, right? You have a one system to perform the module level monitoring. You have another one, traditional on-grid inverter, to do the job, to do the generation job, right? So that's basically two separate monitoring systems. So, but for let's take a look at ours. So as I've introduced, we have the CCA integrated in our inverters. So all the data, so from the hardware side, all data, all the physical cable connection, they will be just much simple, okay, and much easier for the installer to do. And all the data will be collected by the CCA inside our inverters. And all data from the panels, from the optimizers, will also be transmitted to our SAMS portal. Okay, so that means from the hardware side, you will have the from hardware side, the physical connection or the additional expense or the cost spent on the devices will be much smaller using our solution, and also there will be you can monitor all the data on our SAMS portal without any additional app, and also you can check the all the data you want to have. So next part is about the high compatibility with the smart home. And smart home is right now is very popular concept in the recent years, because more and more appliances at the house are becoming are able to connect it to the internet, and also with the AI or integrate or something, the house appliance can work more intellectually. So for our, the first one I want to introduce is our platforms again. So SAMS you are very familiar with. So this is a free platform, which means you can access and you can use it for free for your systems. So compared with some other competitors, some of them will offer some additional service or functions based on with some additional and also requiring additional cost for sure. But for SAMS, we have our own team, and we're keeping adding more and more functions into the platform based on the inverters design, because the inverters hardware they are also being upgraded frequently. So that's why we are put a lot of efforts and investment on our SAMS portal. But from your side, you can use it for free. Okay. So the second one is our Easy Designer system. Easy Designer platform. So this is actually a system design platform. Okay. So it's open freely to all of you. So after the webinar, you can try it. So you can just simply register, use your email address, and you can use it to design a very basic or simple residential solution using this one. Okay, so I think even for me, when I'm using it, it's a very good experience, because you can learn some knowledge, right? You can check whether your design is good or not, something like that. It's a very good platform, not only for you to do some real job, but also it's a platform which is very interesting, and for you to learn some basic PV knowledge by designing some system by yourself. Okay, so this part is a function. We've already I think this is already on the market from GoodWe. So this is our home kit, the load consumption monitoring solution. Okay, so basically right now more and more demands are raised on the markets that clients want to monitor their load consumption, their power consumption, and not only in the daytime but also in the night, right? So I think the reason why we have this one is that we are not only want to collect the data, and we also want to educate the clients educate end users to let them know their power usage habit. Okay, so I think it's very important for everyone to have a basic idea about how much power they consume every day, right? And based on that, you can inquire us or inquire you guys as installers or distributors to know how big the system they can install or appropriate for their house. So this is a very good tool, okay? And I think in the near future, especially for the energy storage part, this one will be a perfect function for them. So this is basically we promote for the users to monitor the loads. And also here, although we put the picture near our inverters, this one can also be used with other brands. Okay, so if you have other inverter from other brands, and also you want to check the load consumption, you can also install this device into your system, into your current system. Okay, so next part is about the is something about a smart home. So it's called TCP/IP protocol. Right now, so like what I've introduced, more and more appliances on the market, they are able to, just like the picture here, they are able to communicate with each other or with or able to be controlled by one control center. Maybe it's something like a smart controller or some main device. Maybe in the near future will be the inverter. Okay, inverter will play the role like that. So they are right now the most popular protocol they're using for this so-called smartphone is the TCP/IP protocol, and our inverters is going to be compatible with this one. So in that means in the near future, our inverters is going to be able to have interaction with your appliances in the house, and it will make the power flow or the power usage more intellectually. And so that's the TCP/IP protocol. Next one is another protocol here. It's called SoundSpec Modbus protocol. So still, it's a specialized or customized Modbus protocol, and this one is actually from the United States. So with this protocol, you can see this is like alliance. Okay, so all the members in this alliance, they are able to be used in a same system. For example, if if there's a brand, they are compatible with SoundSpec, and so that means they can be installed with our inverters in the same site, and they can be monitored with data logger compatible with the SoundSpec Modbus protocol. So this will be very popular requirement on the market. And right now, because if you, for example, for markets like Europe, those great companies in Europe, they are already promoting the inverters, or they're already requiring inverters to be compatible with this SoundSpec protocol, because they are going to have their own controller, they're going to have their own a device to control the inverter's output using the SoundSpec protocol. So next one is actually it's very how to say, it's old-fashioned function, right? Because because we already have this function for maybe more than 4 years already, right? And this is called power limit function. Okay, so if, for example, in some areas or regions in India, if it is not allowed to feed the PV power to the grid, so you can turn on this function on your inverter. For example, you can turn on 100% power limit on your inverter. So under this condition or under this function, activated function, so no more power will be fed back to the grid. Okay, so the loads here can be powered by the PV, by the power from the grid, from the panels, and can also be powered by the electricity we bought from the grid simultaneously. So that means you can still buy power from the grid for sure, but there will be no power feedback to the grid. So that's called a power limit function. So next part will be about the quality and the safety assurance here. So first, as you know that our residential inverters here, they are all fanless design. Okay, so that means there will be no noise at the site. Okay, that's very, very important for households, right? Because if you install a house and the fans will work in full load for heat dissipation, so the sound will be pretty bad, right? Pretty loud. So inverters without fan is actually the perfect. The residential inverters without fan is perfect choice for the house. And although we don't have fans, right? But based on our advanced topology, our inverter's heat dissipation performance is very good, and the derating performance, just like what we have introduced yesterday, is very good. So you don't need to worry about that if you install an inverter in a very closed space without any wind or something, it can still work perfectly. So next one is about the surge protection. Okay, so right now for some models, of our residential models like the MS, we are already able to integrate Type 2 DC-SPD at DC side. Okay, so if, for example, in some regions in India, if we can if the DC-SPD or the type of DC-SPD is required on the inverter, and if you don't have it, maybe for some scenarios, you need to install some stream box or DC combiner box to have this additional safety device installed in it. So, so if you choose our inverters, you can simply understand that you can save the cost spent on the stream box. Okay, so that's something we have. So apart from the designs, also here are some main suppliers of of the key components. So for example, for the IGBT, which is like the heart of the inverter, we use Infineon. Okay, and the sensors like at the DC side to do the current sensoring job, we use Lam, and also we use some other brands. And for the capacitors, we use those capacitors from Farad, Panasonic, and ICs from the TI, Texas Instruments. And for the switches and connectors, for example, we use MC4, and we use Amphenol for the connectors, and we use switches from Centon, these are all renowned brands from the globe and are the main choices for the inverters. So these are the tests we are doing right now. So ATS test, because yesterday I saw a lot of people ask, what is ATS test? So the ATS test is actually a self-developed test platform. So you can see these operators are doing some operations on the platform here. And with the cable connection to the inverters, we will simulate some basic working status for the inverters to check all the parameters of the inverters using the tester platform. Okay, so this is the ATS test. So after ATS test, this is the first time for the ATS test. Then we will send the inverters to this aging room. Okay, so this is a cabinet simulating 45 degrees centigrade. Okay, so the inverters will be put there to make them work in full load with a simulation DC source for at least 8 hours to make sure they can work perfectly in the high temperature environment, which is also requirement from your country as well. So India, because we've sold a lot in India, and then right now we're glad they are working good, and so please have confidence on the high temperature performance of our inverters for sure. So that's a basic 2 tests we are doing for every single inverter manufactured in GoodWe. Also, and this is another interesting certificate. This is called a Reedy reliability certificate. Okay, so we send our 3 kilowatt inverter, the GW3000NS, to the Reedy test lab to test our reliability or the lifespan based on this status, this temperature status. So they do the test under this to simulate the working cycle. We are under this temperature, 35 degrees centigrade, and finally they have a result of our lifespan. Okay, so lifespan of our 3 kilowatt inverter on the 35 degrees centigrade is about 64,100 hours, and the result equals to almost 15 years. Okay, so basically you can understand our inverters can work almost 15 years at 35 degrees centigrade. Okay, so that means our inverters can work longer, much longer than the warranty we basically offer, right? Okay, so the last page. Okay, so the last page here, I present our inverters, our products here. So basically for the residential products, we have the single phase here, this 4 series, and we also have the 3 phase here for this 3 series. And among this 7 series, we have the 1 MPPT models, we have 2 MPPT models, and also we have 3 MPPT models. Okay, so it's basically more options for you to choose based on the rooftop conditions. So we have this, the whole capacity ranges from 700 watt up to, right now should be 25 kilowatt. Okay, so that means if you are using single phase electricity or grid and home, so you can choose this XS, DNS, DSS, and MS, ranging from 300 kilowatt to up to 10 kilowatt. And for some regions, if you are able to use 3-phase grid, you can choose to use the SDT and SDG2 series, ranging from 4 to 25. And also in the near future, the SDT will be replaced by the SDG2. So that's basically the inverters we have for our residential solutions. Okay, thank you very much. That's the introduction of our residential solution. So next, let's welcome Jack from our GoodWe Solar Academy. Oh, sorry, Lucas. Sorry, my mistake. Lucas, to give us an introduction about our export power limit solution. Let's welcome Lucas.
Hello, everyone. Lucas again. Okay. So now I'm going to introduce our export power limit solution. So later I will show you the presentation about our export power limit solution. So any questions? Just now I saw a lot of questions in the chat box. So we already have our local service guys in the Zoom. So after the webinar, so our India colleagues, they will collect all the questions and send to you guys the answers, okay? And let me show you the presentation. Sorry, wait a moment. Okay. Sorry, wait a moment. Okay. As you know, because of the different applications, different requirements, like if you talk about power limit solution, so what's the power limit? So in our side, we split the power limit to two parts. One is output power limit, another one is export power limit. So if you want to just limit the inverter output power, so it's output power limit. So in this application case, there's no loads consumption. Okay, you just want to limit the inverter output power, no loads consumption in this system. But if you have the loads consumption in this system, and you also want to limit the power to the grid, so that's the export power limit. So if you look at the power limit, we should split it to two parts. One is output power limit, another one is export power limit. Normally, the output power limit is applied to the large system, like a commercial system or utility scale system. But if you look at the export power limit, so normally it's used for the residential system or the small commercial system, rooftop systems. So that's the export power limit application scenario. So let's check the details. So the first one, I would like to introduce the output power limit. So you can find the diagram of here. So you can see the panels connect to the inverter connect to the grid. So there's no loads consumption between the inverter and the grid. So if you want to limit the power from the inverter, so you can use the output power limit. So you can find this one, the PV module's capacity is 1.3 megawatt, and the inverter capacity is 1 megawatt, and the maximum you can output 1 megawatt to the grid. But you know, for our product, we have the AC overload ability. So that means sometimes if you have more PV modules on the DC side, so sometimes the inverter output will more than 1 megawatt because of the AC overload ability. So in this case, if you just want to output 1 megawatt to the grid, so you need to limit the inverter output. So in this case, if the inverter capacity is 1 megawatt, so you can set the power limit value is 100% in the inverter display. In the display, you can set the power limit value. So in this case, if the inverter capacity is 1 megawatt, so you can set 100%. So the maximum output power to the grid, it will be 1 megawatt. But in this case, you can see the inverter capacity is 1.1 megawatt. So the maximum output to the grid is 1 megawatt. So you need to set the power limit value in the displays is 90.9% in the display. Okay, so that's the output power limit. No loads consumption. Okay, no loads consumption in the system, and you can set the power limit value in the display directly. So you don't need to buy anything from GoodWe from another companies. You just set the power limit value in the display or from our app SolarGo. So you don't need to buy anything. You just need to see the value in the display. So that's the output power limit. Okay. And this one is export power limit. So in this case, it's a single phase system. So for the single phase system, we have some samples here. So we can find the PV modules connect to the one phase inverter. The inverter capacity is 5 kilowatt, and the load's consumption is 2 kilowatt. And but it's forbidden to output the power to the grid. So the maximum is 0 watt. So that means it's forbidden to output the power to the grid. So in this case, you can set the power limit value in the display is 0%. 0%. So the inverter will only output 2 kilowatt to the loads, and then 0 watt to the grid. Okay. And in this case, you can find the maximum power to the grid can be 1 kilowatt. So in this case, the inverter will output, if I think here the load's consumption is 1 kilowatt and 1 kilowatt to the grid. So the inverter will output 2 kilowatt, 1 kilowatt to the loads and 1 kilowatt to the grid. And in this case, you need to set the power limit value is 20%. So you can calculate because the inverter capacity is 5 kilowatt. So 5 kilowatt, 20% is 1 kilowatt. Okay, 1 kilowatt to the grid. And for the export power limit solution, all the export power limit solution, you need to buy something from GoodWe, like smart meter or CT or something like this. So later I will let you know the details, what's the components, what's the devices you need to buy from GoodWe. And here the 3-phase. So it's also export power limit. It's a 3-phase and a 0 injection. So 0 injection means it's 0 watt to the grid. So you can see for this case, like the phase 1 is 100 kilowatt consumption, and phase 2 is 300 kilowatt consumption, and phase 3 is 200 kilowatt consumption. So the total consumption is about 600 kilowatt. So the inverter will output 200 kilowatt on each phase. Okay, to supply the power to the loads. But for the phase 1, there will be after 100 kilowatt to the loads. So another 100 kilowatt will feed into the grid. But for the phase 2, the inverter output is 200 kilowatt, but the loads consumption is 300 kilowatt. So for phase 2, the loads will get 100 kilowatt power from the grid. And for the phase 3, the inverter output 200 kilowatt. It's just the same with the loads consumption, so 0 kilowatt from the grid. And also, for this case, you need to set the limitation value in the display or in the SolarGo or something in our ProMat software. Later I will let you know. And in this case, it's different with the last one. This one you can set the certain value to the grid. For example, here you can set the maximum it's 900 kilowatt to the grid. So we also take this as a sample. The loads consumption is totally 600 kilowatt, and also can be 900 kilowatt to the grid. So the total power from the inverter it should be 1.5 megawatt. So the inverter will output 500 kilowatt on each phase. And for the phase 1, there will be 400 kilowatt to the grid. For the phase 2, 200 kilowatt. For the phase 3, 300 kilowatt to the grid. So the total power to the grid will be 900 kilowatt. And this one is the zero injection on each phase. So this one is the actually it's a very, very special case. It's only happened in some small countries like Czech Republic, because the grid company that measure the power on each phase. Okay, not like another countries, the grid company measure the consumption on the three phase, the total phase. But in the Czech Republic, the grid company then measure the power on each phase, and they since the electricity bill to the customers also according to the consumption on each phase. So that's why the customers there they ask this question, this function, zero injection on each phase. So in this case, if zero injection on each phase, so the inverter will output according to the lower is the consumption on one phase. Like phase 1 is 100, phase 2 is 300, phase 3 is 200. So the inverter will only output 100 on each phase to make sure the loads only get the power from the grid, not feed the power to the grid. So that's only happened in some certain countries like Czech Republic. So here I will introduce the details how to do the export power limit on different scenarios. So firstly, you need to know whether your inverter support the export power limit function. For example, for this product like NS series, DNS series, SDT G2, and DT series, if you get the inverter, the communication port is like this. So it's blank, so it's without the arc function. The arc actually is not same with yesterday where I introduced the FCR. Here, the arc is not FCR. So here the arc means anti-reverse current. Okay, anti-reverse current. So it's the same. It's similar with the export power limit. So if your inverter is NS, DNS, SDT, G2, and DT, the communication port is like this without the arc. So your inverter your inverter also can do the export power limit, but it's more difficult. It's more complicated. But if your inverter with already have the arc function like this one, the communication port like this one, you can connect the CT or you can connect the meter to the inverter directly. So you can do the export power limit easier. And also for some our new products like XS, MS, DSS, STT, G2, if your inverter here is black, so it's without arc, and here if here is only 2 pins, it's also without arc. But if the inverter you already have the communication ports like this, so that means your inverter already integrate the arc function, the export power limit function. Okay, so firstly, if you want to do the export power limit function, you need to order the specific inverters from the GoodWe. So that's the application scenario for the one piece of the NS and the DNS series with arc communication port. So if your inverter is only one piece, it's NS or DNS series, and it's already integrated the arc function, the export power limit function. So it's very easy. You just need to connect the CT to the inverter with the RS-45 cable. Actually, we also can provide the cable together with the CT, So if you want to do the export power limit, you need to order the inverter from GoodWe with arc function, and then you also need to order this, the CT90 with CT cable. The default cable length is, you can find here. The default CT length is 5 meters. If you think the 5 meters is not enough, so you can also order CT90 and 30. So 30 means the CT cable will be 30 meters. Okay, so you can order the CT from GoodWe together with the CT cable, and the CT cable can be 5 meters and also can be 30 meters. And this one is also one piece, NS or DNS series, but without the arc function. So if the inverter without the arc function, you need to order the GM1000 from GoodWe. Okay, GM1000 is this. It's already including the smart meter and the CT, and also the cable between the smart meter and the CT. So it's also not so difficult, but the GM1000 will be expensive than CT. Okay, so I advise the customer to order the inverter with arc function. If the inverter without the arc function, so the solution will be a little expensive. Okay, because you need to order the GM1000. GM1000 is smart meter combine the CT. Okay. And also you can find the information here. The GM1000 is needed only available from GoodWe. Okay, you only can buy this from GoodWe. You can't buy from another companies. You can't buy it from the market because the smart meter need to communicate with the inverter. So you only can buy it from GoodWe. And the load current should be less than 120 amps. Because of the CT, you can find the CT connect to the main cable of the house, just behind the house meter. So the CT will measure all the power, okay, will also including the loads consumption. So if the loads consumption is less than 120 amps, it's okay, it's fine. But if the loads consumption is higher than 120 amps, so it's another solution that I will introduce. You can't use GM1000 to do it. And this one is one piece access DSS MS inverter with arc. Okay. So it's also just now already introduced. It's same with NS and DNS with arc solution. So you just need to buy the CT90 from GoodWe and connect the CT to the inverter directly. So it's very simple, and also it's the CT cable is optional, 5 meters and 30 meters. If the inverter access DSS MS without arc function, so it's impossible to do the export power limit. Okay, so if you want to use our access DSS and MS inverter to do the export power limit, you need to order the inverter with arc. Okay, with arc. Please remember this. So if you order the inverter without the arc function, you can't to do the export power limit. And this one is also one piece, STT-G1, STT-G2, DT with arc, or SMT or MT inverter. Okay, here is also one piece. So it's a little complicated, but we also have a solution. So here is GM 3,000. So it's also the smart meter, but it's combined with the 3 cities. So you need to connect one city to each phase, and the smart meter connect to the inverter with the RS45 cable. And here it's also you need to remember this. The GM3000 is also only available from GoodWe, and the load consumption should be less than 120 amps on each phase. So here are some parameters for each devices. Here the reaction time, here is the CT diameter reaction time, and the maximum current for each one. So if your total, if your loads total current or main break current is higher than our device's limitation, you need to use the next one. I will introduce SEC 1000. So it's this one, SEC 1000. So if your inverter is one piece, STT-G2 or DT without arc, okay, without arc, you need to use SEC 1000 from GoodWe. So you can find here the inverter connect to the house meter, connect to the grid, and the SEC 1000 the power meter, the power line connect to each phase, and here the CT connect to the CT connect to each phase, and here is RS45 cable connect to the inverter. Then you can control the inverter output power. So in this case, you need to use SEC 1000 also with 3 cities. So this CT, the CT work with SEC 1000, you can buy from GoodWe, and also you can buy from the market, in your local market. But if you buy the CT in your market locally, you need to remember that the secondary ratio of the CT should be 5. Like here it's 250 divide 5. And if your load consumption in your house or in a factory is very high, so you can buy the CT ratio like 500 divide 5. Okay, just remember the secondary ratio should be 5. And here's the multiple pieces. Okay, if your system is the CNI system or the multiple inverters, so you only can use the SEC 1000 from GoodWe to do the export power limit. Like multiple pieces of STT-G1, STT-G2, DT, SMT, or MT series. Like here, multiple inverters. So you only can use SEC 1000. So the connection is the cable connection is same with the last slide. And also, just I already mentioned, the CT can be purchased from GoodWe or from another, just like your local market. But remember, the CT ratio should be 1 number divide 5. Okay. So here is introduction about how to set the parameters for SEC 1000. So if you use SEC 1000, you need to set you need to make the parameter setting in the ProMat. So here you can find its ProMat software. So you can download the ProMat software from our website. So the first step, you need to choose the EasyLogger. And here you need to set the system parameters and the CT ratio, like the ratio of the CT and the total capacity and the power limit. So here the power meter is like how much power you want to fit into the grid. And then choose the export enable here. And then you can see the phase current and phase current and phase power on each phase here. So here is also the meter power. You can get it, inverter power and the load power. And here you can find the status of the connection, series number of the SCC vendor, and here the software version of the SCC vendor. And here you can click the refresh to get the inverter's serial number connect to this SCC vendor. And here you can configure the SCC vendor to the customer router, to the customer switch to do the monitoring, the online monitoring. So just now I already introduced the on-grid inverters export power limit solution. So here I will introduce a hybrid inverter export power limit solution. So for the hybrids, it's very simple, because if you buy our storage inverter, the smart meter and the CT already in the box. So you don't need to buy anything. You don't need to buy any additional device from GoodWe, because the smart meter and the CT already come with the inverter in the package. So you don't need to buy anything. You just need to connect it like this, the diagram of here. After the connection, you just need to open your app, the PV Master. In the PV Master app, you can click the export power limit. Okay, just enable this function, and here you can set the power limit value, how much power you want to export to the grid. So for the hybrid, for storage inverter, it's very simple. Okay, it's very simple. Just need to do it in the app, in the PV Master. And for our hybrid inverter, we also have one premium feature. It's unbalanced export power limit on each phase. Just now I already mentioned in the Czech Republic, because the grid company, they measure the power consumption on each phase. So the customer want to do the export power limit on each phase, but they also want the inverter can output the maximum power to the loads. So you can find this case, like phase 1 is 1 kilowatt, phase 2 is 3 kilowatt, phase 3 is 2 kilowatt. So if the inverter doesn't support the unbalanced export power limit, so the inverter will output 1 kilowatt on each phase. Okay, phase 1 is 1 kilowatt, phase 2 1 kilowatt, phase 3 also 1 kilowatt. So in this case, the customer will get a lot of, will lose a lot of generation on the PV side. So if the inverter can support unbalanced export power limit, so that means the inverter can output the same power on with load consumption on each phase. So you can find here the inverter will output 1 kilowatt for phase 1, 3 kilowatt for phase 2, 2 kilowatt for the phase 3. So in this case, no power to the grid on each phase, but the inverter also can generate the maximum power to the loads. So that's why we said it's the premium function of our ET series of the hybrid inverter. So thank you guys. That's all. And later, my colleague Jack will introduce the storage solution. Oh, sorry. So later you will see the video in our YouTube channel to introduce how to do the export power limit with the SCC 1000 box. Okay.
Hi, I'm Murajan from GoodWe Solar Academy. Today I would like to talk about power export limit is 100 kilowatt. This is only for self-consumption, not feeds the grid. And the project cost is about 4 yuan per watt. In the case of no subsidy, this project's expected return of investment is around 4 to 5 years. Here we use two GW50K empty inverters with SEC 1000 bucks for zero export solution. First thing we should know why we have these features. After realizing that too many different power plants cannot directly connect to the grid, the idea of the zero export function was invented, because that may cause too many problems. Therefore, countries and grid companies set some rules for connecting to the interconnected system of the city. After developments of the PV systems, the local authorities and grid companies made some regulations for selling electricity. But in some areas, the FITs are very low and the application process is very complicated. So some of end users prefer to use solar energy only for self-consumption instead of selling it. Such these cases drove inverter manufacturers to find a solution for zero export and export power limit. There are three main concepts that are very close to each other and use the same working logic. These are zero export, export power limit, and output current limit. First concept is zero export, which blocks the energy that flows to the grid. With that feature, customer can use the energy produced from the PV panels only for self-consumption, but not selling it. The second solution is called export power limit. With that feature, end users can set a limit in accordance with their limit that already set by the grid authority. And the third concept is called output current limit. In some areas, there are some rules about the inverter's output current that feeds to the grid. In these kind of cases, this feature helps us to set the same value that authority wants. To illustrate these features clearly, I would like to explain it with an example. Let's assume you have 1.5 megawatt installed PV power on your rooftop and your factory's consumption is 200 kilowatts. Now let's see how these three features works. In first scenario, if your local grid company does not allow you to sell electricity to the grid, then we have to use zero export function. And the inverters will reduce production to 200 kilowatts to only provide electricity to your own consumption, but won't feed the grid. In second scenario, if your local grid company allows you to sell electricity to the grid with 1 megawatt upper limit, then we have to use export power limit function, and inverter will produce 1.2 megawatt instead of 1.5 megawatts. 200 kilowatts for providing energy your own consumption, and 1 megawatt directly goes to the grid. At third scenario, if you have an output current limit such as 70 amps per each phase, then inverter will reduce the output current in accordance with your output current limit. Here in GoodWe, we provide all these solutions with one external box which is called SEC 1000. In SEC 1000, there is an Easy Logger Pro located inside with 3-phase smart meter. Thanks to it, it's very easy to adjust the active power output, power factor, output current, and we can do string level monitoring. And the connections of the SEC 1000 is very easy. All you need to do is connect RS485 data cables between inverters, and the last one has to connect SEC 1000. That's all. After that, we can easily do all these settings and adjustments easily and even remotely. For the small scale projects, we also have similar solutions. For these solutions, please contact us. Thank you for watching us and see you next time.
Okay. Hi, everyone. This is Jack, and this is my chance to talk about energy storage systems with you guys. Okay. GoodWe is for energy storage systems. GoodWe is focused on residential systems. We also have commercial systems, but in short term it will come out. But mostly today I will talk about the residential energy storage systems. Okay. The first thing I want to talk to you to just have a brief introduction about the energy storage products we have. Generally, we have two kinds of energy storage solutions. The first is hybrids. We call it hybrids. Another part we call it AC coupled. Okay, and from this page we can tell if the model name is start from E, it's hybrids. Okay, like ES, EM, ET, and EH. This is hybrids. Hybrids, it means it's a on-grid and off-grid system together, and it's bidirectional. So in hybrid systems, you can connect PV, connect a battery, connect off-grid loads, and connect on-grid loads, on-grid, and also the grids together in the same unit. So we call it hybrid. Okay, and another part, it's AC coupled. AC coupled, it means is model names that have B, like SBP, BH, and BT. Okay, this is AC coupled. AC coupled, it means it cannot connect solar. Okay, the difference for the general difference from the energy storage is it cannot connect PV systems. It only have grid connection, off-grid loads, and battery. Okay, so normally for AC coupled inverters, it's used with on-grid systems. Okay, it's not used alone, all right? And except for that, we also have ESA. ESA is what we call all-in-one. Means we put the energy storage inverter, the pre-wire box, we call it BOS box, and also the battery in the same cabinet. Okay, this is the unit we have. And no matter it's hybrid or it's coupled, okay, we have single phase, we have three-phase option, and also have low voltage option and high voltage options. Okay, and if you want to tell from the model names, if the model names have H, like EH, like BH, okay, it's used high voltage battery. Okay, and also three-phase ET and BT. It's a three-phase energy storage, hybrid energy storage, and this is a three-phase AC coupled. All three phases, they use high voltage batteries. Okay, for the details you can from here. And from for the residential energy storage systems solutions, we have the minimum of 3 kilowatts, and the max is 10 kilowatts. Okay, for single phase is from 3 to 6 kilowatts. And for three phase, it's 5 to 10 kilowatts. Okay, no matter it's energy storage, it's a hybrid or AC coupled, it's almost the same. Yeah. Okay. And this one is the upcoming products we will have. This is single phase, but it's up to 10 kilowatts. It means we will have a single phase energy storage. This is hybrid. Okay, we will have a single phase hybrid inverter from 5 to 10 kilowatts, single phase, okay, with 4 MPPTs. Okay, this one is 4 MPPTs and use high voltage battery, and single phase is from 5 to 10 kilowatts. Okay, and also have, of course, they have backup supply. Okay, this is the structure, the functions is almost same with the normal and hybrid inverters, but the capacity is up to 10 kilowatts. Okay, this is difference. And this one is not coming yet, but I think in a few months it will come out. If you're interested, you can ask more questions, ask more details from us. Okay. Okay, this one we will start from the operation logic of hybrid inverters, hybrid systems. Okay, here we just take a hybrid system, hybrids as an example. Actually, for each coupled and on-grid inverters together, the logic is almost the same with hybrids. Okay, here we just take a hybrid as example. The first logic, two basic logics. The first logic is if the PV power is enough. Okay, if the PV power have enough, they can charge the battery, they can support loads, they can export grids. Okay, so what's the priority? The priority is they will support loads first, and then if they have enough power, they will charge the battery. Okay, if then the excess power will export grids, Of course, for hybrid systems, you can choose to allow the system to export to grid or not. This is called zero export functions. This is what Lucas told you guys. Okay. And for hybrid systems, like I said, if the PV power is enough, they will support load first. Okay. Here they have two loads. One is backup load, it's an off-grid supply load. Okay. Another is on-grid load, it's connected on grid side. So these two loads, they have no priority. If they support loads, it means these two loads is support together. Okay, they will calculate the general total power of the loads. They will not calculate what is how much is backup, how much is on grid. Okay, they just take all the loads consumptions, okay, together as one, no priority. Then if you charge it through the battery, okay, of course it's support lithium battery first only for now. And in these systems, all the logic is controlled by the smart meter. This smart meter is contained, okay, is attached with the inverter. Okay, it means if you receive the inverter, it will find these components. You don't have to buy it separately. Okay, this is the first basic logic. If the PV power is enough, and another logic is if load power is big. For example, if the PV power is low and the load power is high, so how the load will consumption power from PV battery and grids? The priority will be PV first, then battery, then grid. It means if the load power is high, then the PV production will do its best to support the loads. Then if it's enough, okay, then the rest will be supplied by lithium batteries. Okay, if the lithium battery is still not enough, then the rest power will drain from the grids. Okay, this is the two basic logics. Of course, this is just the basic logics. If you want to change to have your own logics, you can do that on the PV master. The PV master is the commissioning application what we have, okay, only for hybrid inverters. So on the application PV master, you can set your own operation logic you want. Okay, it's not just these two basic logics. They have hundreds different logics. You can do that. You can do that on PV master application. Okay, and for hybrid systems, one of the most important features is they can work without grid. It means work and off-grid mode. And if the grid fails during the operation, and from on-grid mode to off-grid mode switch, this UPS level switch time is 10 milliseconds, less than 10 milliseconds. Okay, so it means most of the house loads, if it's used when the grid is normal and then suddenly the grid shut down, okay, then the whole systems will switch to off-grid supply. Then most of the loads will not stop. It's continuously power supply. Okay, this is a difference from EPS. A lot of suppliers, no matter it's from China or from other countries, their energy storage systems, the off-grid supply, it's EPS supply. This is a very big difference from Gujri. Gujri is a UPS level switch time. It means there's no stop. But EPS, the loads, it means if the grid fails and the loads will shut down for a few seconds, then they will start up again. This is a big difference. Okay, another system is AC retrofit. Like I said, AC retrofit systems, if it's not used alone, it's used with on-grid systems, okay? And here, for the on-grid systems, it's no matter which brand you used. You use GoodWe or use other brands. You use solar systems or you use wind generators, everything, it's fine. It doesn't matter because it's coupled on AC side. So it does not communicate with AC coupled inverters, okay? And so for the basic logics, it's the same. For the basic logic, it's the same with hybrid systems. So what's the difference for hybrids and AC coupled systems? The big difference is the smart meter. The smart meter with AC retrofit inverters. So, sorry, this is wrong. This should be AC retrofit here. The big difference for the smart meter for AC retrofit inverters, they have two cities. Because for AC retrofit inverters, they do not connect PV solar, right? So they have to use with on-grid systems. If they use with on-grid inverters and but they do not communicate with on-grid systems, so they cannot detect how much power produced from PV systems. So that's why we use a smart meter with two cities here. One city is to control all the systems, to control all the basic logics. Another city is connected on the PV system side to detect how much power from on-grid sides, on-grid inverters. Okay, this is the difference. And another difference is if the grid fails for the AC retrofit systems. If the grid fails, it means on-grid inverter cannot work. So the PV cannot work. So another difference is if the grid fails, for AC retrofit systems, they have only battery and backup loads is available. So only battery support backup loads. This is only one operation mode. This is difference. Okay. And this one is paralleling system. For paralleling systems, we support this function only on ET, hybrid inverter, on ET. ET is our three-phase hybrid inverters, use high voltage batteries, okay? And another thing is this paralleling is only on-grid sides. So from the diagram, you can see for each ET, they connect lithium batteries separately, they connect PV separately, and then they connect backup load separately. So only the on-grid side is connected together, okay? And to realize paralleling system, you have to have another device. We call it SEC1000S. It should be SEC1000S. This unit is used to combine all the ETs together as a one. It means if you have this box to do the paralleling with all the ETs, and all the ETs communicate with this box, and all the PV, all the battery, and all the loads will calculate as a unit one. It means in the system, for example, the battery power, they will calculate the total charge or discharge power to all these batteries, to all these three batteries. Okay, and the same with PV. And they calculate the total power of all PV productions. And they will calculate all the load consumptions of all the systems, including backup loads of all the three systems and also on-grid loads together. Okay. For paralleling systems on ET series, it can do parallel max in 10 pieces. It means the system, the paralleling system can be 15 kilowatts to max 100 kilowatts. It means, you know, for ET series, we have 5 kilowatts, 8 kilowatts, and 10 kilowatts. And if you want to do paralleling systems, okay, you can parallel all 10 kilowatts, or you can mix 5, 8, or 10 kilowatts together in the paralleling systems. Okay. And for ET paralleling systems, they can also support unbalanced outputs for the paralleling systems. Okay, for unbalanced output function later in following pages, I will talk about the details. And another feature is we call it the smart control. Smart control is very complicated logic here inside. Again, we have a technical document to talk about these paralleling systems, about the smart control logics. So if yeah, For the smart control system, smart control logics, okay. Later, I will talk about the details, and also we have a technical document to talk about this. If you're interested, you can contact with us to get this document. And for this system, one thing we should point it out again is for the parallel systems, the max is 10 pieces. Max 10 pieces ET is allowed to parallel. It means from two pieces to 10 pieces ET is paralleled. Okay, you cannot parallel more motors together in the same systems for each SE7000, SE7000S. Okay, and this solution is, it's a kind of hybrid and AC retrofit together. Okay, we combined hybrid inverters and AC coupling functions together in these solutions. So in this solution, we use a hybrid inverter like ES or ET. Okay, as is coupled, it means it can connect it together with on-grid systems. Okay, so now you can say it's not only AC coupled inverters who is working with on-grid systems. For hybrids, it can also work with on-grid systems. Okay, so what is the advantages about this solution? Like we talked, for pure AC coupled inverters, if it worked with on-grid systems, if the grid fails, the PV cannot work. So only battery and the backup is working if the grid fails for pure AC coupled inverters. But if you use hybrid inverter with on-grid systems, if the grid fails, okay, this PV cannot work. Okay, this PV system cannot work, but the PV, the solar connected on the hybrid inverter, they can still working. So this is the sorry. So this is the big advantage of hybrid inverter working with on-grid systems. Okay, and for these systems, for all our hybrid inverters, no matter it's single phase or three phase, it can work like this way. And another solution is battery ready function solution. Battery ready solution is what we realized on EH inverters. EH is our hybrid inverter, single phase with high voltage battery. Okay, but for EH inverter, we have another option. It's EH without battery functions. So for EH without battery functions, we call it EHR. Okay, this is what we call battery ready functions. Battery ready functions is just a normal on-grid inverter actually, but they still have backup supply. Okay, backup supply is still there, but they cannot connect the battery. Okay, this is what called battery ready. And you can buy this inverter, and later, maybe a few months later, or 1 year or 2 years later, if you want to add the battery into this system to change it to energy storage, then you can buy another activation code. You can buy another activation code to activate battery function of this inverter. Then you can connect the battery on it. Okay, so if without battery functions, we call it HR, which is a battery ready. The price will, of course, will be lower. And if you buy EH inverters with battery functions, okay, this is a total pure energy storage systems. So the price will be higher. Okay, so this solution is mostly for customers. Before we have customers told us that for now, we don't want to install batteries because battery in our country, lithium battery in our country is not so easy to access. Or maybe the battery price is very high now, and we expect in 1 year or 2 years, the price of the battery will be drop a lot. So we want to use battery, maybe use the battery 1 or 2 years later. So for such situations, such conditions, such requirements, battery ready is the perfect solutions for such conditions. And another solution is ESA. ESA, we call it all-in-one. It means, like in the first page I have talked, this part is a hybrid inverter. This part is a 5 kilowatts hybrid inverter. And this part is pre-wired box. We call it a BOS box. And this part is a battery. We put the battery inside. Okay. For the battery, maybe you have fusions. For the battery, we use, for now, we are compatible with Palantech US series in batteries. And in the short future, maybe in a few weeks, we will have our own battery. Okay, we have GoodWe batteries used with this unit. Okay. And for the pre-wired box, inside we have a battery switch, we have a communication inside, we have a PV disconnect isolator, and I have on-grid and a backup switch. And another feature is here we have a bypass switch. Bypass switch, it means if for example, if the hybrid system fails, they have a report of failure or something, they need maintenance. So you need to stop the whole unit to do the maintenance, right? But if you don't want stop backup supply, because if you stop the whole unit, so the backup supply will also stop. And normally on the back side, you connected important loads, which you don't want to stop power supply. So if you don't want to stop power supply, when you close all the units, you can use the bypass switch to switch the backup supply to on-grid side for a short time, of course. And if the unit is, if the hybrid unit is okay, is healthy again, then you can use the bypass switch to switch it back to backup supply again. Okay. And another solution is about a battery power reservation. Okay, for this one, we have, it's not just two solutions here. Here, I just have two solutions, but we have more than two solutions, okay? First solution is, this is the PV master application. On PV master application, if for the commissioning, you have the option to set different DOD of the battery. Yeah, one is for on-grid use, one is for off-grid use. Okay, so it means, for example, for on-grid DOD, you set to maybe 40%, and off-grid DOD you set it 80%. So it means if the grid is normal, okay, the battery will not discharge all its power. If you reserve a part of its power to use when the grid fails. So this solution is perfect for the market where the grid supply is not stable. Okay, so if you do not have off-grid DOD settings, so it means if the grid is okay and the load power is high, the battery maybe the battery will discharge all its power to supply the loads. So if under this condition, if the grid fails, the battery do not have enough power to supply the loads. So for different DOD solutions here, this is for the scenarios where the public grid is not stable. Okay, and another solution is backup mode. For hybrids or AC coupled systems, on the application you have a basic settings with 4 basic operation modes. The first is a general mode and off-grid mode and also economic modes. Okay, here we don't talk about the details. Here we only focus on the backup modes. Backup modes, it means the battery power, you will reserve all the battery power to be used when the grid is off. So it means if the grid is okay, if the grid is normal, the battery will not discharge. Okay, they will only charge the battery to make sure the battery have enough power if the grid fails, when the grid fails, okay? And another solution is also kind of battery reservation, and it's economical mode. Economical mode, it means you can set charge and discharge time for the battery, okay? So you can charge the battery if the electricity price is lower, and then you can discharge the battery if the grid electricity price is high, okay? And for charge discharge, you have different options, four different options. And in each option, you can set different charge discharge logic. For example, here, I can choose Monday and Tuesday. I follow this logic. I want the Monday and Tuesday to charge the battery from 8 o'clock to 10 o'clock. And from maybe Friday to Saturday, I want to discharge the battery at from 8 o'clock something. Okay, you can set a different charge and discharge logics in different groups. And this 4 different groups is separately. This is the independent logic. Okay, and for discharge and charge, you can set time, and you can set charge or discharge time, discharge power. Okay, so it means you can set the max charge power for the battery during the charge time, and also you can set the max discharge power from the battery, okay, during the discharge time. Okay. And this one is a solution for load monitoring. Also, we call it consumption monitoring. Okay, for consumption monitoring, this function actually is a default function of hybrid inverters and AC coupled systems, because it's realized by the smart meter, and a smart meter is a default component for hybrid inverters and AC coupled inverters or any storage inverters. Okay. So this function will be realized automatically if you connect the whole system correctly. And from here, from the load monitoring, we have to talk about the SAM's monitoring platform of GoodWe. Okay, this is a GoodWe monitoring platform. It's for free, and it's not just for hybrid inverters, of course. It's for both on-grid and hybrid inverters. And for hybrid inverters, it's not just monitoring the production. It's not just the monitoring production of or charge discharge of the battery. They can also calculate how much power from the PV is used by loads, and how much is used to charge the battery, and how much power consumed from the battery by the loads, and how much power is imports from the grid. Okay, this is the calculations. And also they will have a diagram here to show you the 24 hours load power of your house. And you can also check the historical data, of course. And this part is about the features of GoodWe energy storage systems. The first, we call it a one-stop solution. One-stop solution, it means all the components, all the necessary components for energy storage inverters from GoodWe. Okay, it's already contained with in the inverter box with the inverter. So it means if you receive the inverter, you don't have to worry about if you don't have to buy another components to make sure the whole system will work normally. You don't have to worry about that, because when you receive the inverter, all the components, all the necessary required components is already inside the box with the inverter. Okay, and here I want to talk about this one. It's Bluetooth module. Bluetooth module is not coming yet because you still have a few months, I think, maybe 2 or 3 months to have Bluetooth option. So Bluetooth, this option, sorry, this is an option. This components, okay, this Bluetooth USB disk is used for each motor to do the commissioning, because in some place, sometimes customer complains that the Wi-Fi signal is not stable. So when you do the commissioning, and sometimes it's disconnected, and sometimes it's not stable, we cannot do the commissioning successfully. So to resolve these problems, we have added a Bluetooth module, which is used for hybrids, for any storage inverter commissioning only. Okay. So in the short futures, the Bluetooth module will be as a default component with all the inverters, all the hybrid inverters. Okay, and this one is for SEC 1000. The connector is for ET paralleling. Okay, ET parallel. So for ET parallel, you have to communicate, data chain all the communication cables of all the inverters, then connected to the SEC 1000, right? So you have to use a Y connector here, a splitter here to communicate to data chain all the inverters, all the 18 inverters. Okay. Oh, sorry. And another feature actually we also talk about here is for hybrid inverters and also AC coupled inverters from Gujri. We have preset communication cables with the inverters. So it means these two communication cables, you don't have to map it by yourself when you do the installation. One cable is BMS communication to lithium batteries. Another is the smart meter communication cables. Okay. For a battery communication cable, its default is 3 meters. Okay. And for smart meter communication cable, the default length is 10 meters. So normally it's enough for a house used, for the house residential and storage inverters. The length is enough. Of course, if you want to extend the cable, you can cut off this cable and you can extend. The length of the cables. Okay. For smart meters, you can max extend 100 meter, and for a battery cable, you can extend max to 10 meters. Okay, this is another feature. We call it UPS level switch time. It means from on-grid mode to off-grid mode. It's the switch time is less than 10 milliseconds. It's a UPS level, and it's an interrupted power supply level. Okay, so we have a brief introduction here. For on-grid modes, okay, this is inverter side, this is the on-grid side, this is a backup supply. Okay, and on-grid modes, they have two relays here. They have two parts of the relays. Here is closed, so it means if the grid is normal, the backup supply and on-grid supply is connected in the same electrical circuit. So that's why, you know, in the previous page I have talked, if the grid is normal, off-grid loads and on-grid loads supply, they have no priorities for these two loads. So this is why, because if the grid is normal, the backup output and the on-grid output actually is in the same parallel system. Okay, so that's why they do not have priorities. Okay, so if it's switched from the off-grid mode, if the grid fails, so this relays will open for anti-aliasing protection, and this also will be open. This will also open because there's no power from the grid side, but these relays will be closed to make sure the backup sides still have power supply from the inverter side. So this is the general working of UPS switch time, switch logic. Okay, and this part is we can call it just kind of features, because in the previous pages we have talked about a lot of features about of GoodWe and storage inverters. Like we have a preset communication cables. We have a free application to do the commissioning, and we also we have put all the components inside in components, and all the preset, all the necessary cables. You know, we have preset it. We have preset it. A lot of it's not all the cables. You know, a lot of cables we have preset. So that's why for the installation of all the energy storage systems, we can save a lot of time. At least we can save this time to make the communication cables, right? And also on the application, on the PMaster application commissioning, here we don't talk about the details here. If you're interested, you can contact us. But on the PMaster, the commissioning process is very simple, very easy. Okay, it's very practical, and it just take maybe just a few minutes. Okay, you can finish all the commissioning, including Wi-Fi configuration. Okay, so it's a very easy installation for GoodWe energy storage systems. Okay, and this part is a general evaluation about the installation time of all the energy storage systems of GoodWe. And we have experienced technical guys to do the wiring of all the systems, and we calculate time. Okay, so for if it's an very experienced installer or technicians, okay, for the whole system connection, maybe it's just take half an hour. You can finish all the wirings. Okay, of course, it is for very experienced installers. Okay, but normally for installation, it will be less than 1 hour. You can finish all. So for this one, you can save a lot of times on the installation. Okay, this is so that's why we put it here as a very important features of energy storage inverters of GoodWe. And another features is about unbalanced operation. For unbalanced outputs, this is only realized on three-phase energy storage inverters, ET and BT. Okay. So what is unbalanced outputs? Unbalanced output functions, it means on each phase, because for ET it's a three-phase, and the BT also three-phase, right? And for the three phases, unbalanced output ability, it means on each phase, it can produce different power. Okay, because normally for solar inverters, for three-phase solar inverters, the three-phase on the AC side, the three-phase output, on each phase, the output must be the same. But for ET and BT, we have a breakthrough on the technologies, so it can realize unbalanced output functions. Okay, so this function is very important for some place like they need zero export function, because the production, it cannot solar production cannot be exported to grid. So if the solar production cannot export to grids, and on each phase you connect different loads, and if the inverter cannot output unbalanced power, so it means each phase they have to output the same power. Okay, so on if for example the first phase is 1 kilowatts load, and the second phase is 3 kilowatts loads. So it means if this inverter does not support unbalanced output ability, all the three phases, they can output only 1 kilowatts. And for phase 1, for phase 2, and phase 3, load power is higher than 1 kilowatts. So on these two phases, they have to buy from the grids. So this is a big waste of solar power, right? So that's why unbalanced output is very important for places with the zero export functions. And except for unbalanced output functions, we have already developed another functions. We call it Imbalance Charge. Okay, Imbalance Charge is only realized on BT series, because Imbalance Charge is only available for AC coupled. It's not for hybrid, because for hybrids, they can connect to PV and the PV can charge the battery, right? But for AC coupled inverters, they have to work with on-grid inverters, on-grid systems. And the power charge the battery mostly is from the on-grid systems. But the on-grid system, they will have to connect to the AC side first. So the battery charge for AC coupled inverters, it's actually from AC side to DC side, then charge the battery, right? So if the inverter cannot support unbalanced charge, it means the charge power to the AC coupled inverters must be the same on all the three phases. Okay, so this is the same logic with the unbalanced outputs actually. If the inverter cannot support unbalanced charge, so they have a lot waste about solar power. Okay, but for BT, for our three-phase AC coupled inverters, we have realized this function. Okay, they can do unbalanced charge for the batteries connected on the AC coupled. So for these two solutions, we have some important features we should talk about here. The first is it's 100% unbalanced output. And also, of course, the charge, unbalanced charge is also 100% unbalanced. So what is 100% unbalanced? 100% unbalanced, it means the max output or charge on each phase. Okay, the max power charge or output on each phase is 33% of the nominal of the inverter. So it means for all the three phases, the output or charge, it could be different from 0 kilowatts to 3.3 kilowatts or 14 kilowatts inverters. Okay, so it means it can output, for example, this phase, on phase 1, there's no loads. Okay, so phase 1, they do not output power. The output power on phase 1 is 0 kilowatts. But on phase 2, they have 3 kilowatts loads. So on phase 2, they can output 3 kilowatts power. Okay, and 0 kilowatts on phase 1 and 3 kilowatts on phase 2, they can realize at the same time. It's not separate time. It's the same time they can realize. So this is what we call unbalance. The same logic on the charge, unbalanced charge is the same. And another one is both on backup and on-grid sides, we can realize unbalanced output. It means on the grid side, unbalanced function is an option. You can activate this function on the application to do commissioning. But on the backup side, you don't have to do the commissioning. It's default function. It's always realized unbalanced output, because on the backup side, it's not connected to the grid. All right. So it means you can connect different load power on the backup sides. You don't have to worry if they can support all the loads. Okay, they can do that. They can do, because the inverter can do unbalanced outputs. Also in the market, we have heard other brands, their hybrid inverters, they can also realize unbalanced outputs on the backup side. But as we know, they cannot realize 100% unbalanced outputs. It means they cannot realize unbalanced 100%. They can realize only maybe 30% difference from each phases. It's not 100% difference. Okay, and this one optional on the application. Like I said, on grids, unbalanced output, you can choose to activate it or deactivate it on the application. Okay, it depends on you if you need it or not. And no extra device. Okay, no extra device means that this function is realized by the inverter itself. We don't have to use external device to realize these functions. And also we know in China we have another suppliers of hybrid inverters. They can realize unbalanced output, but they need an external device to realize these functions. Okay, this is a lot difference. Okay, And this part is about the batteries we are compatible. As we have talked for our energy storage inverters, we have the option for low voltage batteries and high voltage batteries. Right? For low voltage batteries, we have BYD, LG Chem, and Alpha, Palantec, Dynis. It's just all low voltage. Low voltage means it's a 48 volts about the battery nominal voltage. Okay. And for high voltage batteries, for like ET, EH, and BH, and BT, okay, these all use high voltage batteries. For our high voltage batteries, for now we are compatible with BYD and also Palantec. LG Chem is on the way; it's not come out yet, but it will come soon. And for Dynis, yeah, of course, it's already compatible. And except for all these batteries, GoodWe will also have our own battery, both on low voltage and high voltage. And the battery will come out, I think, in a few months, something. I cannot tell you the detailed time, but you can contact us for the details about our own battery. Okay. And this part is about, we call it virtual power plant, VPP, but it's not just a virtual power plant. It's this function of the motors is they can fit into all the EMS systems, is energy management systems like VPP, like microgrids. Okay, a lot of scenarios, operation scenarios. And to realize this situation, to fit in this situation, it's because our inverters have Modbus, open Modbus RTU protocols. Okay, and we are doing TCP, or TCP will be another option protocol is used to communicate with other devices, with the controllers or something to realize VPP, to realize microgrids or something. And also now we are planning to compatible with SunSpec. And after we do compatibility with SunSpec, I think we will have a lot of market on the EMS systems. Okay, so this is what we talked today about the energy storage systems. Okay, now we switch to our okay, so our friend.
It's me again, Craig. Okay, so thank you very much for Jack's sharing about our energy storage solutions. Again, thank you very much for everyone attending the webinars, this 2 days webinars, and also thank you for the questions. So if you have any questions, please contact us, contact our Indian team, and also later we will upload our webinars videos on our GoodWe Solar Academy's YouTube channel. So if you're interested in that, please go to check out the videos on our channels. And if you need presentations, please contact our Indian teams in the panelists. Okay, and okay, that's all. Thank you very much. Bye bye.